Today's problem, gold mine problem, difficulty medium. Given a gold mine called matte matrix, we'll have a 2D matrix as the input. Each field in the mine contains a positive integer, which is the amount of gold in tons. Initially, the miner can start from any row in the first column. Okay. From a given cell, the miner can move to the cell diagonally up to the right, to the right, or the cell diagonally down to the right, find the maximum amount of gold that he can collect until he can no longer move. All right, and then there's some examples here that are a little bit hard to figure out without sort of sketching them out, which we'll do. Matrix size, width and height is between 1 and 500. The numbers in the matrix would be between 0 and 100. Expected complexity, n times m, that sounds right. Company tags, Flipkart, Amazon, Samsung. I looked up what Flipkart was because it was showing up a lot. Apparently it's an Indian e-commerce company. It's kind of funny to look at you go to the homepage and the prices are in Indian currency. So, you first look at it and you're going, why am I paying $15,000 for a t-shirt, but anyway, it's a different currency. Topic tags, dynamic programming, right? Okay, let's take a look at one of these. All right, let me get a pen. All right, we'll do the first one. So wait, I still don't have the pen. All right, I got it now. So we got 1, 3, 3, and then we have 2, 1, 4, and then we have 0, 6, 4. Okay. Now, we can leave the first column here as is. Going across, now the 3 here, you can get there either from the 1 or the 2, but we're trying to maximize this. So we'll say, let's come in from the 2, all right? And get rid of the 3, and we'll make it 5. The 1, we can come in from 1, 2, or 0. We'll come in from the 2, and we'll make that 3. And then the 6, we can come in from the 2 or the 0. Let's come in from the 2, and we'll make that 8. All right. Going to the last column here, the 3. We can get to the 3 from the 5 or the 3. Let's come in from the 5. That'll make that, you know what? I don't even have to erase that really. I can just make the 3 into an 8. Okay, the 4. Now from the 4, we can get there from the 5, from the 3, or from the 8. So we'll want to come in from the 8. That would make that 12. Same thing is going to be true here. We can come in from the 3 or the 8. Let me just make this simpler, but that would be 12. All right, now we can go down this column and say, what is the max gold? Turned out to be a tie. 12. What is it? Whoa. oh, I changed them so you can't see it anymore. But it's saying you can go 2, 6, 4. Now this used to be a 6, but yeah, you would go 2, 6, and 4. Are there 2 4s there? 1, 2, 2, 1, 4. Yeah, either way, 2, 6, 4, and it's going to be 12. So, okay, let's see how to implement that. All right, so let's initialize a couple of variables for length and width, n and m, and we're gonna do this column by column. So the outer loop is going to be j for the column. Again, we're going to start in the second column. We're going to leave the first column as is, and we will go. Let's see. We'll go down the column, and for each element in the column, we'll figure out what is the number on the left. So that would be at j minus 1. We'll figure what would be the number left and up, diagonally up to the left. Now, if I is 0, that's the first row. There isn't going to be anything diagonally up to the left. So we would set that to 0. If I is greater than 0, then the number diagonally up to the left would be at I minus 1, j minus 1, and then left down. If I equals n minus 1, we're in the last row, so there isn't going to be anything diagonally left and down. Again, we'll set that to 0. If I is less than n minus 1, then left and down is going to be at I plus 1, j minus 1. All right, good. We got 3 values there, and we want to pick the biggest one. So we've got a math max on the left, on left up, and on left down. So we'll iterate through the matrix or the mine that way. Column by column. When we're done, we're going to take a look in column m minus 1, which is the last column. We'll iterate from 0 to n. We'll go from top to bottom, and we will get the max gold. That's it. Let me just compile this as a sanity check, because I changed it a little bit. Okay, good. Submit. Just kind of slow. It's just been kind of slow tonight. I don't know. A lot of people doing practice problems. Oh, wait, it's moving. Okay, good. Yeah, so dynamic programming problem, 2D array doesn't require any extra space because we can use the original matrix to build up the solution. So go ahead and like the video, subscribe. You'll get problem of the day in your inbox, and we'll see you next time.